Vice President, CDFT Bharat Forge, Dr. Datta, Director, Gridscore Solutions, Dr. Lande, Additional Director, DRDO, BRDE, Dr. Mandal, Scientist, NTPC Netra, Dr. Anjali Chatterjee, Chief Scientist, CMERI, Dr. Rajiv Garg, Chief Scientist, CRRI, Dr. Murmu, Nodal Scientist for Automation and Robotics, Subvertical of Civil Infrastructure and Civil Engineering and Infrastructure team, Dr. D.N. Ray, Dr. Bishit, CMERI, and scientists from Technology Management Directorate, CSIR, speakers, scientists, invitees, academicians, researchers, industry partners, ladies and gentlemen. A good morning to you all. I'm happy and glad to be present in this session of iConnect event on robotics for civil infrastructure inspection and manufacturing under the Civil Infrastructure and Engineering team. On behalf of the CIE team, I welcome you all to this event. Civil infrastructure such as bridges, chimneys, cooling towers, tunnels, underground and underwater assets provide essential services. However, as they age, they may suffer from a variety of defects due to structural degradation. In-time maintenance are necessary to keep them functional as well as to prevent unexpected damages. Monitoring existing infrastructure assets, it's vital to determine the safety of its continued use and to allow for improved management of the infrastructure networks, especially during extreme events. Infrastructure inspection must be carried out regularly, and the most widely used method is visually assess the structure, that is visual inspection. Visual inspection data can be unreliable as results are reliant on the inspector's own judgment and experience. Visual observation of the cracks on the surface of the structure is an important parameter and are difficult to detect with the naked eye during inspection. Usually, photographs are not taken of the entire structure during the physical inspection, hence monitoring changes of structural condition is difficult. Additionally, human inspection generally require machinery or scaffolding to inspect areas where access is limited. Hazardous, sometimes the access, the structure itself will be hazardous as they may impose a health or safety risk. Additional costs are involved and often disrupts operations. Say, for example, if you have to do an inspection of a bridge, we have to stop the traffic. Current inspection and condition assessment thus practices rely mainly on manual data capturing and analysis, which can be risky, time consuming, and error prone. With the fast development of digital technologies, there is a growing trend of research on improving infrastructure inspection with sensing devices such as unmanned aerial vehicles and Internet of Things. However, such inspection processes are not fully automated and need to be operated and controlled by human beings, which still requires extra working hours and training in relevant skills. In addition, accurate interpretation of the inspection data requires a high level of experience and expertise. UAVs are generally maneuverable and their flexibility means they can provide visual access in the form of photo or real-time videos and access difficult to reach areas quickly and at relatively low costs. Many uses of UAVs are emerging, as we have seen in recent times. The delivery of lightweight items to customers, like medicines were being delivered during this COVID time. And three-dimensional models produced from aerial imagery can help to inspect infrastructure and assess situation. So a recent paper also tells that the market opportunity for UAV technology indicates that 45% of the total market for UAV technology relates to construction and infrastructure inspection activities. The recent developments in sensor technology also enables other type of data collection. Say, for example, thermal images are also possible. UAVs are often regarded as low-cost option as both initial purchase costs and the operational costs compared to other equivalent labor hours are low. Some areas where more focus is required is automated data interpretation. So we have advanced methods such as computer vision, artificial intelligence, machine learning, and to interpret different types of sensing data is also and evaluate the infrastructure conditions where more focus is required. And also development of a multi-sensory robotic system with the ability of real-time inspection and data transfer. So sometimes the system is expected to travel autonomously for inspecting the infrastructure and also perform real-time data interpretation for condition assessment. And also common recent digital twin of the infrastructure is also important, so that this data, whatever is collected from the field, has to be updated in the numerical model, as well as this will help us to prevent catastrophic failures and other. This also involves again artificial intelligence, computer vision, and it is a efficient and reliable way for the structural health monitoring also. Integration of the heterogeneous data to facilitate infrastructure management and decision making. So this all these data, which are of different forms, has to be integrated, and that will help in giving the decision making. The people who are using the things can take the decisions based on the expertise which is available elsewhere. And the approaches should be developed to integrate that different types of data. So many devices are there, and these devices are also existing on different platforms. So there should be an integrated approach which would help to integrate all these things. And intelligence robots represent the sophisticated incorporation of robotics, cyber physical system, and artificial intelligence. A great variety of intelligent robots are finding exciting applications and playing important roles in civil infrastructure systems. Taking the field of, say, for example, structural health monitoring, researchers have investigated the concept of mobile sensors, where these robots can autonomously move around the structure and conveniently change measurement locations. And also small size crawling and flying robots are particularly useful in structural health monitoring and inspection. Meanwhile, intelligent robotics and machineries of much larger size also play important role in construction and maintenance of civil infrastructure. So combination of robotics, electronics, network systems, pattern recognition, and intelligent computing has also thrust a significant amount of work in smart structural technologies. So in this technical session, you will be listening more on this from eminent speakers and researchers. I would like to conclude with a Tirukural, Nyalam Karudinum Kaikudum, Kalam Karudi Idattar Sei, which means if a person thinks to win over the world, he may accomplish if he acts in the right time and at the right place. Thank you all.
Thank you, madam, for your information on the directions. Obviously, the all the country along with the CSIR, the whole CSIR fraternity as well as industries, they are working in this direction, and the advanced topics which we are working as a research area will be translated to this commercial requirement of various industries soon. So, in this regard, thanks once again. Now, I will request Sri Ramesh Srigod, Vice President, CDFD Bharat Forge, to provide some insights on the robotics work which they are carrying out in the country. So, Ramesh sir, please.
Good morning. Can everyone hear me?
Yes, yes, sir.
Okay. Can you see my screen?
Yes, sir. Yes, sir.
Okay. Good morning, everyone, and thank you for giving opportunity to participate in Azadi Ka Amrut Mahotsav. It's a great pleasure and feeling good to be part of this session. I'm a part of manufacturing industry and mainly forging industry. So I will be sharing our experience, the journey of no robot case to the highly sophisticated robots used in forging industry. let me introduce about my company for maybe 1 minute. We are Bharat Forge is a part of $3 billion Kalyani Group. We have more than 10 plus factories operations globally, mainly in European countries and US also, and almost 10,000 plus global workforce. We are the world's largest forging company and serving various sectors including automotive, railways, power, oil and gas, marine, aerospace. Our customers are mainly looking at a Bharat Forge as a preferred technology and engineering partner. They come to us with their problems, and we try to give them solutions, not only product, but solutions also. We have a largest repository of metallurgical knowledge, mainly in metal forming. We have a global footprint, mainly, as I told you, mainly in Europe and US, and almost a total capacity of 600,000 tons per annum, and supplying to all major automobile, aerospace, and oil and gas sector companies. Okay, so as I told you, we are a forging company, and I will be sharing our experience in using robots in manufacturing industry. Almost in 1990, we were doing the forging operations completely manually, and that process was totally inefficient, then personal skill dependent. Also, the operating cost was very high because of manual operations. Energy cost was very high, people requirement was very high, and then cycle times were not constant. So different issues were there, and this cost was very high. Also, by virtue of process, it was a hazardous process to do the manual operations in case of forging manufacturing. And these whole things were putting a lot of limitations on the business expansion, mainly in export of our product, because quality norms and audit norms were very stringent, and it was not possible to fulfill those norms. So that time it was decided to go for a completely automatic forging process with lean and predictable lean manufacturing production line and predictable process, which can give good results in product quality. Mainly consistency in product quality is the key issue here. Also, once you go for automation and fixed cycle time mode, then you get consistency, and your production cost also goes down. Same time, in automation, human beings are away from the machines and handling systems, so safety factors also improve a lot. And this finally gives you the opening up of export market, which we observed in last 20 years. And after we started automation. We have become a world leader in forging industry in last 20 years. So basically, in automation, we were assuming that robots will help us in material handling, and then mostly they will take up repetitive nature of job, and human being will take care of decision making and monitoring of the process. The same time, we are getting a consistent cycle time because of use of robotics and gantries on the production lines, as you can program those for your requirements, and those programs will remain as it is, and it will keep giving us exact same cycle time, and that same cycle time is giving the best product quality and repeatability also. In our industry and in our business, the positioning of a material on the dies and tools is a very important, which makes direct impact on the product quality. So robotics is taking care of those issues which was not possible in manual handling. So coming to selection of a robot, Selection criteria in our case is mainly the payload and weight carrying capacity of those robots. When we go for selection of the robot, the part weight and the handling tooling weight is very important. We have to take care of these two factors in selecting the robots. And definitely for achieving your required cycle time, the speed specifications are also very important. Then going forward, compatibility of robot in your line layout or production layout is also very important. And for that, working envelope of robot makes a major difference. You have to consider your layout and the working envelope of robot while selecting the robot. And same time, the local service and spares availability is also important, mainly when you are operating in 24 by 7 mode. That makes a big difference. Okay, these are some important data points which we need to take care while selecting robot. As I told you, working envelope, then the payload and the payload change as per your CG change. When you move robots away from its center, then CG changes and its payload also changes. So you have to take care of those things, and then only you can select the robot so that it will give you a good life and consistency in operation. In Bharat Forge, mainly there are different types of robots, but in Bharat Forge mainly we use a Cartesian robots, and those are electric robots. These are linear motions, X, Y, Z, C axis. Those moves in those axes, and mainly for high payloads. As hydraulic drives are there, those are mainly suitable for higher payloads. We have almost seven numbers of such robots in the range of 250 to 350 kg payload range. And then most of our robots are articulated robots. These articulated robots are mainly multi-axis robots working in interpolation and almost work like a human arm. And those are servo robots, electrical servo robots. So you get very flexibility in operations in complex applications and in complicated layouts. You can use these robots and they give you very good performance in those types of conditions. And then latest technology which is coming and we have also started using is a collaborative robots. Many people call it a cobot. The cobot is a mainly in articulated robots safety point of view, human interference and the co-sharing is not possible because it's very risky. Collaborative robots are mainly articulated robots only, but they have a different sensing arrangement where if a human being comes in contact, they will stop immediately. So you have to decide in which areas you have to use a collaborative robot and in which area you need to use articulated robots. Mainly in assemblies and inspection, you can use a collaborative robot, and that's where human safety is important. And these robots share workspace safely with human beings. We have started using these robots recently. We are gaining experience also with these robots. So maybe in future we will use more such robots. Now, 2D layout is a very important in deciding the use of robot and your cycle time, and then how you want to move your process. So, if you have a 2D drawing capabilities and layout designing capabilities, then this can be the starting point, and this is sufficient to start using robots in the layout. But if you have a 3D layout capabilities, this gives you the major advantage that you can visualize and find out the interferences and limitations of the movements and sequences of robots, and which can help you in implementing project very fast without actually spending time on shop floor to find out these interferences and other issues. So this is the typical simulation part of the robots. If you have a 3D models, you can simulate these conditions, and these simulation programs can directly you can load in the robot, and you get almost same program on the production lines. Just see small touch-ups and other adjustments are required, and you can immediately use those programs. Now, in case of use of robot and automation from manual to automation of production line, you get major advantages. And productivity boost is the main big advantage we get. And as the productivity is boosting, your operating and energy cost goes down, because your idle energy cost and manpower cost keep going down. Then robots can do the multitasking. Human being can take care of one job at a time. But if you have a robot, then if you design its arm and tools in maybe thinking all the operations, then the robots can do the multitasking and reduce the cycle time of your process. Also, with the use of robot and automation, the reliability and elimination of human error is the important aspect. Most of the time on the continuous production lines, you will see that 15 to 20% of the issues comes because of human errors and the fatigue of human being. So those can be eliminated completely, and then reliability also improves a lot. Also, the robots can perform the detailed task. Hello. Robots can perform detailed task in complex situations and give the greater precision. Anyone have any question?
On.
Once you go for use of robots in automation, then employees can get a better opportunity. We can train them and move up in the company to take care of skilled jobs and other jobs where decision making is needed. Also, robots can work in hazardous environment. If you select robot properly, then those robots can work in hazardous environment where human beings cannot. And same time, there are disadvantages of automation and robots, but those can be taken care if you plan the if you take actions on those disadvantages. Job loss due to elimination of certain positions like operations and everything. This is the main disadvantage, but that also you can take care by training that manpower for skilled jobs on robots itself. Then capital cost is a major issue, but with a productivity payback period goes down, and you can recover that cost very fast. And third disadvantage is once you go for automation and robotics, you need a skilled manpower either in your company or agencies around your area to take care of the issues and design factors and all related actions, which add a lot of cost. Now, once you go for automation and use of robotics, the skill set involved in you need to have these skill sets in your organization or around your organization to take care of robotics installation, commissioning, and then later on the maintenance and other issues. Computer and PLCs and programming part is very important. Without that, without this skill set,
ఏమి లేదు అన్ని
you
ఆయన
cannot.
అడుగుతాం
Without this skill, you cannot use robot in your organization. Also,
ఎందుకంటే
same thing for tooling purpose, robotic arm purpose, hydraulic and pneumatic knowledge is also must. As robots are driven by either hydraulic or electrical power, electrical and hydraulic servo knowledge is also important from maintenance point of view. And then you must have a capability to do the layouts and tool design, where you can use either we use AutoCAD and Inventor softwares in our organization. Also, 3D modeling and simulation is also very important to get a maximum benefit from use of robot in automatic production lines, where we now we use a 3D Max, RoboGuide, and RoboStudio softwares. Also, computer networking and interface skill is also very important. It depends. I will recommend if you are a 24/7 working company and productivity is also very important. Then having all these skill set inside your organization is very important. It gives you major benefit. We have in-house capabilities in all these areas. Moving forward, we have started working on the vision system where a robot can take care of a quality part also, the product quality, and then traceability part also. So we have started working on collaboration of robot with vision systems. Also for trouble-free functioning of robot, artificial intelligence and predictive maintenance capabilities are also important. And we have started connecting our robots on the ThingWorks platform, IoT-based platform, where we will use the data which we are getting from robot controller of servo torque, currents, and other information which is available on the robot network. And we will use that information to predict failures or abnormal situations so that we can take care of these things in advance and your uptime is taken care properly. So this is also going on in our factory. The next one is product history tracking. If we install a laser marking system on the robot and with artificial intelligence, if we can mark product and lot of data can be stored in operations related or process related data can be stored in those codes, and we can use this information later on for other processes and in analysis also. Now, once you go for networking and connecting robots on the cloud platform and those things, cybersecurity is also very important. So we are working on cybersecurity space also very strongly, so that processes are not interrupted and outside interference will not generate any issues in the process. Also, one more part we want to take care that now the robot programming is very complicated and somewhat skill part. Want to convert that part to the simple one, and the CAD program which we use for our product making. So layout is already there, then product design is already there. So can we generate the robot coordinates directly from the CAD program and feed those coordinates to robot directly? And it will start, it will eliminate the function of touch up of robot and programming of robots. So we are moving in these directions, and I hope we will achieve these targets in next 1 year, and all robots, robotic functions in our factory will be available on ThingWorks platform, and we can control all the data and monitor the complete functioning of robots on the computer and maybe mobile to give us a very higher uptime of robot. I hope this information will be useful to the people who are listening this presentation, and maybe you can contact me. I will share my email ID. So if whatever information you want, I can share with you. No problem. Thank you. Thank you very much.
Thank you, sir, for your informative lesson. And thanks a lot for letting us know the skill set available and required for using robots in the manufacturing domain. Obviously, I will request the participants who want to ask questions and other things. We have a panel discussion just before ending this event around 11:55 a.m. So I will
Right.
request her so that you can ask a question at that particular event panel discussion due to very shortage of time. Thank you, sir, once
Okay.
again. Now, I
Thank you.
will request Dr. Rajiv Kumar Garg, Chief Scientist, CRRI, to present his work on bridge and other structure inspection which they are carrying out. Dr. Garg, please.
Are you seeing this?
Yes, 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 sir. Make it full screen. It's visible.
Good morning. Dr. Anand Valli, Director SCRC, Dr. Anjali, Director at CMERI, Nandi, Ray, and experts at CSIR Laboratory, experts from industry. We are working at Central Road Research Institute, particularly for roads and bridges. And some of the technologies we have developed are as follows. Primarily, bridges are very important aspect in roads and transportation. They are complex systems, and their maintenance is very important to for the economy. So the civil infrastructure require continuous field inspection, condition monitoring, and that is very essential for maintenance and management. So first activity we would like to discuss is bridge, mobile bridge inspection unit, MBIU we say. In unfolded situation, it is the second diagram mounted on trucks. It can be mounted on rail or any other also. And when it is folded fully ready to operation function and say under the bridge, that is the first figure. So essentially, these mobile bridge inspection units are electromechanical devices mounted on a vehicle or rail for a smooth movement of functioning at a particular location, which allows inspection of bridges or similar structures. One such technology has been developed by Road Research Institute and our sister laboratories, Central Mechanical Engineering Research Institute. And this has been patented also. There are many arms, as you see, which moves arms. Ultimately, the function of functional arm, which can be scaled within inside the bridge also, and it can be up and down, so that an engineer can go down and inspect the various parts of the bridges. It is a fully automatic, and the functional and structural design comply the American code, Indian Road Congress codes, and Europe Indian standards. It was patented and it was also awarded an innovation award by NRDC. Two licensees are producing it commercially in India, and this has led to local manufacturing. At least 4 units are commercially produced and serving successfully in field. Each unit costs roughly 160 lakhs locally manufactured, and imported units are somewhere 250 lakhs to 320 lakhs. There are an interesting observation what we noted. us that many other companies, other than the CSI licensees, have started production locally. The old machines were also renewed by the technicians which were involved while working for our MBIU. The technology readiness level is fully in line because the machine has been tested, accredited by Indian Road Congress, and its commercially produced units are serving in the field. The first prototype itself, which we use at Road Research Institute CRRI, over 20 project sites we have used it. In the state of Jharkhand, all major bridges were inspected using MBIU, and hundreds other bridges have been tested using this machine. And its use has given a new dimension to inspection and safe inspection of bridges. Other commercially produced units are also serving successfully in India. As far as concerned future direction, I would like to bring your notice. It is rather humor aspect that you see the first diagram on right side. Our indigenous machine, at least 4 units are there in market, and they all are bought by private companies. And that I feel at my personal level that our technology is well accepted by market. So what we at CSIR feels that we have to maintain the sustainability of the technology, and we have to be committed for the continual research and development for sustenance in the market of this MBIU technology. And of course, we look forward for export potential and wider uses, say railways and others. I can say that in last COVID season, due to COVID, probably our some of the licenses are not able to export. They are not able to focus on. But we'll look at again. And if you look at the life cycle technology of this technology, we are already in competition stage and we are giving a very good competition to all imported units. That's why it's important, interesting to look at it. Next technology is related to remote pilot aerial vehicles or drone. And I request my colleague Dr. Naveen Kaur to take the floor. Thank you.
Thank you, sir. The second activity which we would like to introduce here um, is the remotely piloted aerial vehicle. So here I would like to emphasize that the drones, they have drastically transformed the way we have been traditionally doing the bridge inspections. So in CRRI, we are using this technology for performing the bridge inspection or performing. We have started to do some trials for the non-destructive testing of the bridges. So in this, I would like to mention about the two technologies under this RPAV. The first technology in which we are on a particular bridge and use the drones for performing the visual inspection as well as generating the 3D model of that particular bridge by capturing the geo-referenced photographs of that bridge. In the second technology, I would like to introduce what we are doing here in CRRI to perform the non-destructive testing of this using the RPAV. So if we talk about the technology level, technology 1, it has reached the TRL level of 7. So we have done the implementation of this technology in the field by capturing the data. And also for the technology level 2, we have reached the TRL level 3, which we will be discussing in detail in upcoming slides. Next, please. So in detail, if let's discuss about the technology 1. So what we have done, in a particular bridge, we captured the geo-referenced photographs of that particular bridge in a particular protocol. So all the photographs, they were having X, Y, and Z information associated with them, and we stitched them together and developed this 3D model. Now, we have tried to compare the dimensions by measuring the dimensions at the site physically, and also we acquired the data from the 3D model which we generated for that particular bridge. And we found that we could achieve an accuracy of 97 to even 100% at some locations. So the 3D model, which was generated by stitching the photographs, that was pretty much accurate in the physical dimension, geometry dimension terms. Now, in India, there are so many bridges for which the drawings are not available. So if the bridge is inaccessible and it is tough to measure the dimensions of the bridge by physically, manually going there, we can generate the 3D model of that particular bridge and get the dimensions and develop the 3D, develop the structural geometry drawings of that particular bridge. Another application of this 3D model is the replacement of visual inspection. For example, in this particular case, we can see there is a restricted bearing action at a particular location. Also, we observed the leakages at some locations in the bridge. So this could also act as a replacement of the visual inspection. Next slide, please. Now, another application of this 3D model is the damage mapping. Now, in this particular 3D model, we end up capturing thousands of photographs through the RPAV. But the problem is, if we want to locate the damages in that from those photographs, it becomes really cumbersome. So what we are doing is, next please, next slide please. For example, these are two different kind of damages: exposed reinforcement and some shear cracks. What we did, we designate them with a damage A and a damage B. Now, since these photographs are having XYZ location associated with them, so they will go and they will sit at their appropriate location. Next, please. So they will go and sit at their appropriate location in the 3D model. So it becomes easier for us to visualize the location of the damage and to see what kind of damages are present at which place. Next slide, please. Now, in the previous slide, what I've shown you, that's being done manually. But in future for this technology one, what we are thinking is, now we at CRRI are involved in performing bridge inspection since almost last 20 to 25 years. So we have huge amount of data for all the different type of damages available with us. So what we can do, we can develop some programs which we can make that this is a damage spelling leak in the witness previous slide. That's a previous slide, sir. Yeah. So in another damage is leaching of concrete, exposed reinforcement. So what we can do, we can designate them as different kind of damages, and we develop some machine learning programs based on AI maybe. Then that program will automatically detect that this is the particular kind of damage, and it will go and it sit at its appropriate location. So we will end up in determining the severity of damage. That is, we can know what's the type of damage, what is the location of the damage in the structure, and we can also quantify that damage. For example, in the case of honeycombing, so if we see this E, it is a typical honeycombing damage in the structure. So we can determine the area of honeycombing in the whole structure. What is the area of honeycombing in the bridge? What is the length of the cracks in the whole bridge? So that's how we can perform the quantification using the machine learning and AI. Next slide, please. Next technology under RPAV is developing a vibro integrity sensing device. So what we are doing here is, in this particular device, this device can perform the traditional 4 different kind of non-destructive testings. Now this we have already applied a patent for this. It can be used as a standalone device for performing the entity of the bridge, and also it is designed in such a way that it can be integrated with the RPAV. Now the future of this technology too is that we are right now working on integration of this WinSD device with the RPAV. Thank you.
Thank Thank you, madam, and obviously, thank you, Dr. Gaur, for such a wonderful presentation. We are very much delighted to hear you about this use of mobile bridge inspection, which was developed in association with CSIR, CMERI, and also the work carried out using drone. It has a huge potential in the future. So with this, thank you once again to your team. I will request now Dr. Bhav Lange, Additional Director VRD, for the next presentation. Dr. Lange, please. Dr. Lange, uh, Dr. Lange, please. Dr. Lange, are you available? So, sorry, might be some problem. Let me go to next presentation. Dr. Supriyo Datto, Director, Gridco Solution Private Limited. Dr. Datto, are you available?
Good morning. Yes, I'm available.
Yes. So, we will like to hear from you regarding the presentation. We will take up the last presentation of Dr. Lange later on. Okay. So, Dr.
Okay.
Datto, please.
Yes. Are you able to? Okay.
निकालना बाहर से उधर से हाँ यहाँ पे लिख के चल जाता है वो अरे चल जाता है
Good morning to the established to the esteemed panelists from CSIR, CMRI, and CRRI, and to industry specialists from Bharat Forge. Today's topic of discussion from my side will be usage of robotics for rebar cage formation. As you are aware of, that rebar cage is a very primary usage element in terms of any construction projects. So this is something where there is a lot of requirement of automation, and there has been a special projects which has been done currently, and we are going to share with you a lot of inputs on that project. Now, if you look at the rebar cage formation today in industry, from the manufacturing point of view, all companies have CNC bar formation and bending machines, and they have able to achieve good tolerances in terms of the accuracies for going forward to robotic automation. Also, for post formation of rebar cage, they have casting technologies to ensure that they are able to produce the castings and able to deliver the projects. But the pain area of today's industry in the infrastructure area is the rebar cage formation, which affects the project timelines. And that's where robotics has become a very vital part, and it is more of robotics and application. So if you have heard about the presentation from Mr. Shrigod, sir from Bharat Forge, he had talked more about robots. This current presentation will be more about the application engineering in terms of applicability of these robots. So if you look at a rebar cage is something, in case any of the panelists are not aware of it, it consists of bars which are welded together, to give the strength. And this structure is then used to be casted and used in a infrastructure project. So now, why are we talking about rebar cage, and what is the issues in terms of rebar cage manufacturing, and why you should go to robotics is primarily, if you look at it, rebar cage consists of multiple parts. So it is currently being done very manually, and it is very skill intensive because all the parts have to be in position and have to be done in a proper way. Number two, what is happening is, because our country is growing at a very fast pace, we need to have the infrastructure projects at multiple locations, and we have to adapt new designs. So because of that, a lot of flexible manufacturing has stepped in. So there is a critical stress in terms of using automation in the rebar cage. And lastly, but not the least, is these rebar cages are very quality intensive, because these are what actually provides the strength to the structure. Now, coming to the application, if you look at the application of a rebar cage, so I'll just show you the formation of a rebar cage. So rebar cage consists of links which are placed in a direction, and what a robot has to do is it has to place the links in V slots. Primarily, these are more fixture oriented in the and then it has to place the uh, long bars in a 90-degree fashion. So the complexity of the rebar cage is exactly like a sheet metal in automotive, that is formation of car bodies, is the perpendicularity and the tolerances of the structure of the rebar cages are something which gives the final shape to the structure of the rebar cage, and finally to the main construction. So this placing links in the V slots is something which is very critical. Now, why robotics is required is, if you look at it, the links are multiple, and this requires a very faster and accurate placement to be done. So basically, articulate robots, if they are mounted on gantries, and they are able to, do this activity in a very high throughput areas. Now, the other area is, if you look at a rebar cage today, like in automotive, sheet metal car body is around 3 meters. In the construction industries, the rebar cages, the main bar is somewhere between 2.5 to 3.5 meters. In some cases, it's even 4 meters. So what happens is, these bars have to be inserted inside these link bars, which are positioned out here. So articulate robot is something which is able to do the same at a very fast pace. So if you look at it, it is picking up it from fixtures, and it is able to insert the bars exactly in this profile. So as Mr. Shigod has explained, why you require an articulate robot out in this space is because you need to actually duplicate it exactly the way the human beings does. The only thing is, here has to be more of 3D gantries and robots mounted on gantries or rails. Okay, now if you look from a layout perspective, if the main purpose of the automation and robotics is to to go for a higher throughput. And if you look at it today, a typical rebar cage manual output, one section, what I have shown in this particular case, is takes around 45 minutes to manufacture, with say a welder and two helpers, and that too, the welder being a very specific and a very specialized person. Whereas with a robot, you can actually scale down the output to 15 to 20 minutes, maybe even further down to 10 minutes, once you have stabilized the throughput of the area and optimize the layout. Now, coming to the question is, what are the engineering factors which are required in terms of this rebar cage automation? Because right now what we have talked about is placement of the bars and placement of the links, but is it so simple? And why infrastructure or robotic automation has taken so much of time, not only in India but all over the world? The primary function is, the biggest problem is, it has got multiple parts, and part fitting through specialized trolleys are required for all the bars and sections. Currently, even the robot systems houses, the end customers or the manufacturers, OEMs who are manufacturing this rebar cage, don't have that kind of requisite personnel to understand the kind of specialized trolleys which are required for this kind of bars and sections, which are optimized for robotic handling applications. And and number two, the second part is also that there is a lot of need for commonization of trolley. The layout optimization is also a process. So these are the things which are a part of this engineering activity, which is there. A lot of research needs to be done in this area. Second is the part holding location. In if you look at a rebar cage, if you look at a typical automotive application, you use a n number of clamps and just hold on to the parts at a different locations. But with rebar cage, it's very difficult because it's difficult to put n number of clamps because one, there's lack of space. Number two, it is very difficult to accommodate so many points for multiple types of designs which are going to be manufactured from that fixture. So what is done is it is just referencing based on a V group areas which is there. So this takes a lot of bandwidth, and in terms of project and project management. And the challenge in the entire layout compared to automotive is in terms of rebar cage manufacturing is the fixtures have to be very stationary. The fixtures are located at the areas where they have been assembled, because once you have put in the bars in the fixtures, you cannot allow the fixtures to move because it becomes very unstable. So the layout is more of gantry based robots and rail based robots running from station to station to complete the work. It's just the reverse of the automotive layouts. And the application part, you need to have a gripper which is able to handle, variable diameter of bars. Now coming to the areas where a lot of research is required, and I hope that in the coming years we will be actively working between industry and research organizations. There are two areas which are very critical. If you look at the section which is there on my right hand side, so you have a bar and you have a U-link bar. So the typical formation of a rebar cage is when you join this bar to the U-link bar, and this gives the shape to the final rebar cage. Because what you have done is you have put the link bars in perpendicular to the bars, but with the joining of the U-link bar, you are giving shape to this structure. Now for this joining, there is a requirement of a handling robot has to pick up the U-bar from a trolley, and it has to butt it against the main bar, and a welding robot has to weld it together. So this is known as collaborative joining of application. So current projects which are being done in India are more of collaborative joining. But worldwide, there are a lot of countries where a lot of research is being done in terms of the robotic tying out of joints. In many places, people are doing it with manual. There are a lot of manual tools which are available for tying up the critical joints. But in terms of the application, in terms of the robotic, there has not been much development. Companies are trying it, and this is somewhere where research and product development is required in India. Now, once this formation is done, the beauty about the rebar cages is then like an automotive is you can just carry on the welding. The simulation below shows a rebar cage where we have optimized it to the layouts in India. That's once formed, the fixture is horizontal, and you are welding the rebar cage in a horizontal formation itself. And this is a typical Indian way of doing things. The other areas is in certain countries, people have not opted for a handling application in totality. They have made the rebar cage in a fixture, and they are doing it in a horizontal formation with multiple robots. So if you look at it, they are doing it in a vertical configuration, and they have placed this part, and they are doing it in a vertical way. So both the options are available, and I think a lot of development has to be done, and there are unique ways of doing this application. So this brings an end to my session, and if you do have any queries, please do send me those queries, and I will be happy to share with you all the inputs. Thank you.
Thank you, Dr. Dotto, for your very nice presentation. Obviously, robot can do this type of work, this type of monotonous and heavy jobs. But as working in the field of robotics, it will take a little bit time. And obviously, CSIR can collaborate with you in this regard, stepwise, for stepwise solving wires, and then finally the full welding. It will be a very good application, obviously. So I will take up other means any questions on this particular presentation in the panel discussion. So thank you once again. I will move to the next presentation. Dr. Lange is available now. Okay, so let us move to the presentation by Dr. Abhijit Mondal, scientist, NTPC Netra, who are working in application of robotics in this power plant for last few years. So, Dr. Mondal, welcome. We are ready or eager to hear from you. Dr. Mondal, please.
Oh, so now presentation is visible?
Yes, visible, and you are also audible, please.
Okay. So good morning, all the respected panelists and all the co-presenter and all the respected attendees. So today I'll be giving up my presentation on application of robotics in power plants for operation and maintenance. Basically, I am from an NTPC's R&D, which is called Netra. And as you know, NTPC is one of the largest energy conglomerate of the country. And since its inception in 1975, it has established itself as the dominant power major with presence in entire value chain of the power generation business. From fossil fuel, it has forayed into generating electricity via hydro, nuclear, renewable energy sources. This foray is playing a major role in lowering its carbon footprint by reducing greenhouse gas emission. NTPC, I mean, its generation capacity is almost 70,000 megawatt, and another 16,000 megawatt is under construction. So you can think about the magnitude we operate in, and it's almost the country's 1/5, electricity generation by us. As the demand for regular and uninterrupted electric power supply has made it imperative for the power generating utilities to maintain high reliability of the components. Hence, regular monitoring and maintenance activity for the assessment of structural integrity assumed considerable importance and became a fast growing industrial domain. Preventive maintenance is always better to avoid any failure leading to huge financial loss. Thermal power plant is one of the riskiest possible industrial environment with complex operations and maintenance as well as safety and security challenges. The present changing power scenario has created the situation even more complex. Many of the coal power plants are subjected to flexible operations due to the preferences of renewables during the daytime, and that is substantially low in the night. These fluctuating loading condition causes further stress to the critical component. Sometimes the excessive stress produced by these adverse conditions can result in catastrophic accidents with preventive potentially massive social and environmental ripple effects. If we are not deploying the advanced methods for early detections of these kind of problems or faults. To meet the challenges of cost-effective yet efficient and accurate monitoring, either of thermoelectric or hydroelectric power plants, a new and more innovative inspection and monitoring solution has to be adopted. And because of that, the use of robotics in power plants for operation and maintenance is growing very fast. This is really a good news for the future of power plant management and optimizations. So if we see, drones have been part of power plant inspection for some years. In many cases, they can limit or eliminate the need to send workers to examine difficult to access areas such as boiler, stacks, chimneys, cooling towers, etc. So if we just if we look in what are the areas where presently we are using this, so especially in power plant for inspection and maintenance of steel and civil structure, there we are using. So as all my earlier presenter also showing, it can be effectively used to monitor all sort of structures, which earlier was not possible because of this thing. Another area where we are also routinely using, that is maintenance of switchyard and solar PV for hotspot detections. So if you see, this is the hotspot. So if you do use it, you can see which are the area where temperature is going up. And similarly for solar panel, we can do hotspots, cold spot, and diode failures and other problem where routinely we are using it. And for detection of spontaneous combustion in coal yards, there also we are using if any hotspot is forming in the coal yards or not. And similarly for volumetric analysis of coal stock to get a clarity about your inventory management. So there also we are using drones. And for terrain mapping and aerial photography by monitoring, especially progress of the hydro project and other areas, you can use it. And this is the area where, I mean, different companies are already readily supplying these robots and drone robots kind of stuff. So it is not our photograph. I have taken it from, it is a Korean company. They are giving it. And it's a readily available product, and it is very effective to clean your solar panel. All the earlier things are for outdoor applications, and there is another area where we are thinking of using drones, that is for drones for boiler inspection inside the boiler. It's a massive structure where if we can use it. It is the drone we are in a process of developing with a company, and that the trial run is going on to get the clarity about the inside of the boiler. So these are the area where we are doing this thing. So apart from the above applications, unmanned vehicle can enter piping, go underwater, and survey power transmissions line, wind turbines blades from varying angles while providing better coverage and more effective maintenance. So those are the another area where we can also use. Apart from quick inspection, there is also a reduction in travel and inspection time on geographically dispersed assets, as drone can carry multiple data capture systems that allow the operator to take several data readings in one flight. This data system can include HD video, high resolution photographs, infrared images, UV corona photographs, like that. So there is allowing complete mapping of a facility and creation of a digital module of the plant. So these are the important sensors. So along with the cameras, we are putting to get all the information what I was telling earlier. So this part I'm just going to skip because already repeatedly told what are the benefits over the existing process. Although in our sorry. So what are the major challenges for applications of drone in power plant? The major areas is like fly close to the it is inability to fly close to the object and flying in an environment with high electromagnetic interference and adverse weather conditions. So these are the major challenges. If you are using drone, you should be careful. So just a second. So when the testing units are too heavy or bulky for a drone, the areas are inaccessible, robotic inspection are a suitable alternative. So robotics in power plant can replace workers at the point of applications, as enabling operator to remotely access hazardous and inaccessible zones in a safe and cost-effective manner. So this is another area where we are routinely using it, but this is the product we initially bought it from an Israel-based company, and then we were trying to indigenize it. I mean, along with Dadri. So we install it at Dadri for a plant because, as you know, efficiency of the solar panel goes drastically down if there is a thick layer of dust. So it is absolutely required. So initially we got this, and then we were trying to collaborate with IIT Bombay if we can indigenize this thing. But in our case, additional feature we are trying to add. Earlier was absolutely dry robotic cleaning, but we were trying to add water if it is possible. Another important area for robotic system and visual inspection in power plant area, like if you see do the little bit of research, you will find most of the original equipment manufacturer like Alstom, like GE, they have made these kind of robots. Those are readily available, but for long distance pipe and larger diameter pipe inspections. But we were looking for a solutions to inspect our headers, which substantially higher dimensions, but there was a restriction in the entry point. Entry point was not that big. So presently, video image-scope is used to inspect the inside boiler header, and what the requirement for header, if there is any blockage in the tubes which is coming out from the header, so that will create a catastrophic failure, means tube leakage. So means another 3-4 days shutdowns of a bigger plant. So and that costs around 6 to 10 crore for a bigger plant. So you are going to lose that. So if you are doing inspection in a routine basis, especially during the overhauling, you can ensure that at least there will be no failure because of the blockage. But there was a limitation of the existing tool. So we were requesting CMERI's help, and they played a crucial role in developing and sorting out the problem. So the constraint. So with their help, this product was developed, and then the product we have already filed the patent. It's a joint patent. And then we deployed this tool along with the CMERI team at different NTPC locations. And then we do the more advanced versions, so to improve its reliability, it improves its ruggedness so that it can sustain the field conditions. And since 2019, we are using it for different plants, and almost 14 of NTPC's plants has already been inspected using this thing, around 17 units, and number of headers is more than 210 number of headers. So if you see what exactly it does, yes, so just a video if it runs. Yeah. So this is the time. These are the entry restricted area where you can put the header inside, and then it will go and get you the full clarity about the header. inside picture. And if you see, these are the foreign objects in my left. These are the foreign objects. Sometimes it's present. So if it blocks or chokes the hole inside, so that will create a tube leakage in the boiler. Now we are trying to go for the next level, because whatever foreign objects we are getting inside, we are just planning to remove it. So some kind of retrieval mechanism along with the robot. So that will be our next phase of development. Yes, another important area for inspection is for underwater pump and reservoir in this thing. So if you see, just to formulate the problem, if you see water is the essential component for power plant, and average thousands of liters of water per second are required to for the operations of the power plant. And the water is supplied to the plant from nearby water bodies, reservoir, rivers, lakes, etc., and often carried weeds, grass, plants, logs, debris, etc., which can keep on storing in the sump for water intake of the CW pump. So these are the area of the CW pump where sometimes these kind of foreign bodies comes and gradually deposits, and that chokes the impeller of this thing. And only presently either human divers are employed, or the pump is evacuated for the inspection. These takes require significant amount of time, and so we were looking for a solution. But yeah, so just to get the better clarity of this picture, the whole objective of this pump house is to pump the water to the cooling tower, huge quantity of water. So I was telling, and so there is a restricted entry where you can put some kind of robot and check the bottom of the pump. Yeah, so these are the already available solutions for these kind of similar kind of applications. But when we were exploring the possible solution for this, all the existing readily available tools were not sufficient because of the kind of constraint we were having, and the kind of turbidity of the water is there in this thing. So then we were trying to again we collaborated with CMER, and with their help this product was developed, and then this another patent was filed for this product. And after the successful demo, so if you see, it is a real demonstration at our NTPC plant. So these are the area where robot is going and inspecting the CW pumps impeller area. So these are the results we have got, and that the developed system has been field tested in one of the NTPC's plants during its annual overhauling, and we were happy, and yes, it can serve the purpose, the conditions we are having in the power plant. So now in the next step, what we were trying, there is another problem in our hydro power plant, where these turbine blades, if you see here, it is there. I'm like this is our own plant. It is in NTPC's coal dam. If you see, so you have a dam, then reservoir. This is your turbine house. And this is the turbine blade. So sometimes because of the contaminants in the water, this blade gets eroded, and any foreign body also may comes here and damage the turbine blade. So you may find damages, erosion. So inspection of these blades is always helpful to maintain the healthiness of your turbine. And at the same time, healthiness or integrity assessment of the dam is required to improve its dam's life itself. Because if you see a hydro power plant, the life of the hydro power plant is the life of its dam. So this is also another requirement. So we were already having some idea about underwater robot. So we are thinking if we can do some indigenous tools which can help us in inspecting this thing. So if you see the turbine floor, it's almost, the elevation is minus 500 meter. And there is just recently in 2020, the GE has readily made available their own underwater drone submarine for inspection of hydro turbines. So we are thinking if we can indigenize similar kind of tool for our own applications. Yeah, so another area where we worked, and because in boiler, no, so a lot of time we face problem because of the boiler tube erosion, and it's almost 100-meter length boiler. So if you want to inspect the entire boiler, so then I mean manually you can't even imagine. So earlier we uh, do selected boiler tube thickness measurement using making scaffolding inside the boiler. So now and as that was a selected area, so most of the time you miss if there are some area where substantial thickness reduction has happened. So we took this problem, and we are trying to make some kind of magnetic crawler which can crawl or from the entire boiler. So that product was, I mean, with our effort for last 3 years, we took some help from BARC and some Canadian company, and finally that product was also developed by us and patented. And then for thickness mapping, we were trying to develop sensors, so that was also done, and we were putting the sensors here, and those are also patented. So, and another area where as of now don't have any solutions, right, but there is a requirement in situ inspection of generator using robot. Although there is a company MD&A, so they can give you solutions. So this robot will go like this way, and if there is any fault inside that generator winding or something like that, so you will get this thing. We only do the video image copy. You put the video image scope readily available in the market and get the visual images. But if you are sending, you can send some kind of robots along with all the sensors required, so that will be a beneficial. And another area where we are working, that is for long inspection of long distance pipeline. So that is also another important area, because most of the time you're
हॅलो
yep.
माझं आणि मृत्युंजय सिंगचे टू रिक्वेशन होतं टू
Hello.
अप्रुव्हल
Hello, hello. Please,
Yes.
please,
So
Sakshak, please mute yourself, please.
so
Dr. Mohan, a little bit faster, please.
yes. Yeah, so this is the area, these are the project we are currently working on. One is for long distance pipeline inspection, and another one is, I was telling, in situ inspections of generator using robot. So these are the two other area where we are working. So in my summary, what I can say, the use of robotics in power plant is positively impacting O&M in the power industry. As technology is advancing rapidly, many utilities are taking advantage of third-party companies specializing in robotics operations because of its advantageous feature. And most of the available drones and robots are imported and exorbitantly expensive because of the limited supplier. Hence, scope for indigenizations of these types of drones and robots are enormous. We at Netra attempted to develop a couple of such tools indigenously along with our CSIR partners and sometimes IIT, and subsequently implemented those in successfully. The development of technological tools from the idea stage to commercial product takes substantial time. If the progression of the development work is not continuous and steady, this time gap increases substantially. So extensive efforts are required to commercialize any such tools or technology. And recent efforts have concentrated in minimizing this gap, and however, the extent of work needed to overcome the encountered problem are really huge. So in spite of such a huge obstruction, couple of such technologies, as I was telling, has reached up to product level, we believe, but commercially those are not became successful because further improvement and reliability studies are required. But we hope possibilities are huge and it will be successful someday. Thank you. Thank you for your time. Yes.
Thank you, Dr. Mondol. Thanks a lot. It is nice to see that a number of problems are there. And on behalf of CSIR, obviously, we are trying to provide solution to you. So in the upcoming days, also, we will like to collaborate. All our other CSIR laboratories are there, expert in a different domain. So we will like to collaborate in the future also. Thanks once again for your nice
And
presentation.
special thanks to you and your team and Mr. Karmakar, because of your help. At least two problems we solved it, and those became very useful product for us. Thank you once again. All the hard work you and your team have invested to develop these two products. Okay, thank you.
Thank you, sir. Thank you, sir. Now I will request Dr. Bhau Lange, Head Electrical and Electronic System and Additional Director VRD for presentation. Welcome, Lange sir. So kindly start presenting. Yes. Your screen is just coming. Yes. Just now the presentation. No, screen is visible now. Just open up the presentation.
I hope my presentation is visible now. Dr. Ray?
Yes. You can start, please.
Okay. Respected chairman of the session, all CSIR lab directors present here, all other senior scientists, ladies and gentlemen. Very good morning to all of you. I am B.A. Lange, scientist from VRD DRDO. I will speak on EV HEV defense perspective. In the sense, what I would like to convey the message here is this EV electric vehicle and hybrid electric vehicle platforms are best suited for some unmanned vehicle platforms also. That is the theme of my talk. In my presentation, I will focus basically on EV, HEV, the status and some case studies done by VRD, that is DRDO. My presentation will be, first of all, we will go through why this EV electric vehicles and hybrid electric vehicles, vehicle basics, its different configurations available, and it will follow what are the key challenges for this, and what is the military interest in these HEVs and electric vehicles. And at VRD, we have developed some these hybrid vehicles like parallel hybrid and series hybrid. I would like to explain that, and at the end, conclusion. First of all, we will go through why do everybody want to go for electric vehicle and these hybrid vehicles basically. This data, date back, this is old data, but just I want to correlate it. In 2000, for 6 billion people, the 700 million vehicles were there. But if this data is extrapolated, then in 2050, for the population of 10 billion, the number of vehicles required will be 2.5 billion. This many vehicles will be available. And then just you can imagine with the this many vehicles in the market, what will happen to air, health of quality of the air available. Time again, people, you must have heard regarding the quality of the air available in Delhi also, due to number of vehicles and other reasons also. What I want to highlight is that in the coming future, number of vehicles in the market will be too many. And all these vehicles will be leading to these emission problems then that are related to health issues basically due to emissions. Then the second problem is related to this energy demand, world energy demand. Here you can see most of the demand is made by these fossil fuels like coal, oil and natural gas. And there are very few energy sources, renewable energy sources who are contributing to this. So what I want to convey is that this energy from these renewable energy sources is very far from reality. And what we need to do is this fossil fuel consumption should be reduced by half or less. Okay, then one has to see how do we can reduce this fossil fuel consumption. Uh, Fossil fuel till that this is a major contributor, but now renewable energy sources like wind, solar, bio, nuclear these are also far away from reality. But here again, how to reduce it? To reduce this consumption of these fossil fuels, what we need to do is we have to promote these hybrid vehicles or CNG based vehicles. Then diesel emission should be regulated. Gasoline, one has to use the gasoline. Then use of biofuels. Then one has to promote the hydrogen based and fuel cell based vehicles. This is the one way to do it. Then after this, after saying why this EV and HEV are required, then one has to see what is the problem with the present vehicles. Why do matlab these emissions are there, and how we are spending the energy or how we are spending this fuel. Basically, if you can see in the vehicle specifically, engine losses are almost 60%. Engine idling loss is almost 20%. Accessories, driveline loss, aero loss, energy lost in rolling resistances and braking are comparatively less. So what I want to convey the message is the losses in the engine are too high, and that losses are followed by engine losses when the engine is idling. And here this is a pictorial representation wherein you can see where the energy is spent and how much energy is spent. Here you can see whatever fuel you are giving, let's say that is 100% energy, then out of this 100%, 62% is the loss in the engine itself, 17% in engine idling, remaining 18% in the drive line, and 2.2% loss is there in accessories. This is how the spending is there. The same is for the car on the highway driving, almost similar figures, but numbers are little bit different when you are driving the vehicle on highway. Then the one has to see where is the potential for improving the efficiency. Wherein what one has to see is the energy conversion efficiency. Okay, one has to opt for these higher efficient cycles. Then one has to consider lean burn operation of the engine. Then variable valve timings, variable compression ratio, friction reduction also one has to consider using better material and lubricants. Then one has to see heat loss reduction, how we can use the smart cooling systems. Okay, and one has to think on sophisticated and anticipatory engine controls nowadays, which are available using AI, then AR and VR. Uh, then the potential for efficiency improvement is basically on engine operating efficiency per se is one can downsize the engine. It means indirectly you are saying you go for hybrid. Then this continuously variable transmission or more stepless transmission one can use. Then the other concept is power split. That is again nothing but a hybrid vehicle. Then variable displacement, that is cylinder cut out at lighter load, torque compensation required during transient. This is also again a hybrid. Then minimization of inefficiency and engine operation. Indirectly you are saying one has to think on the hybrid, that is electric vehicles or hybrid vehicles. Then further is significant energy is lost in engine idling also. Then that is also one can go for these battery operated vehicles. And kinetic energy lost can be recovered using regenerative braking in the sense, but that is possible in electric vehicles only. Then here how we can use this IC engine disadvantages. Basically that can be done by downsizing the engines without losing its performance. Then one has to use for these auxiliary power switch, auxiliary power, which can be hydraulic, electric. Then lightweight materials one has to opt for. Then better thermal management. Okay, and one can use the fuels favorable to the environment. Okay, which have the sustainable source. And one has to give the fresh look of the complete mobility system per se and energy conversion process and its efficiency. So I will not speak much on this now because I have already explained this. Now straight away I am coming to these operating patterns of IC engine. What I want to convey is that whenever the engine is to be operated, then it has to be operated in this optimal operating region. And here you can see this optimal operating region of the engine is you can see the crankshaft speed and the power. What I want to convey the message is that the engine losses are higher at low speeds. Very low speeds the engine losses are very high. And after that at one particular speed again that engine is not operating it at its optimum operation region. So there is one particular region wherein you can operate the engine so that you can drive the maximum from the engine, and that's where these EVs and HEVs are coming into picture. Then now after this, basically one has to understand what is hybrid vehicle. Hybrid vehicle is basically the vehicle which combines two or more sources of power. Okay, which are directly or indirectly will be driving the transmission. Most hybrid cars on the road nowadays are gasoline electric hybrids. Okay, electric car basically it has a set of batteries which that provide electricity to an electric motor, and finally to the, and that motor finally turns the transmission, and transmission will finally drive the wheels. Okay, electric car however produces almost no pollution, but it can only go up to 50 to 100 miles. Nowadays this range is up to matlab 400 kilometers available. The vehicle manufacturers in India now they're claiming the range up to 400 kilometers. This is old data. This is a typical configuration of the vehicle wherein we can see the battery is there, electric motor, engine. This is a basically hybrid. Then you can see the gearbox is also required, and this converter or power converter, in the sense if you are using the battery and motor is AC, then at that time you need to convert this DC to AC, and that's where the inverter is coming into picture. This is a typical electric vehicle configuration. Now here, this is the conceptual illustration or configuration wherein you can see these are the wheels. I want to drive this transmission, mechanical transmission, using the motor. So the motor is finally driving the transmission, and then one can see how I am driving the motor. Motor is driven with the help of a motor drive. Okay, and finally this drive is getting the command from vehicle controller, and this vehicle controller is interfaced with the brake and accelerator. So this is the chain basically. This brake, accelerator, then vehicle controller, power, motor drive, motor, and then transmission, and finally power is going to the wheels. But here in this particular chain, you can see the other auxiliaries are also coming into picture. Like this motor drive should get the power. This motor should get the power. That power is coming through this particular link. That is battery charger, then the batteries, and finally the power to this motor drive. And here in this case, you can have power management unit also, and you can convert this power voltage available at the battery to different voltage levels to power up the other auxiliaries. So the different links on this side slide, you can see this is the mechanical link, the black one is electric link, and another is the controller link, matlab control as circuits. So this is the total the configuration and the elements which will be present on the electric vehicle. And here this particular here I will explain you basically why do these EV and HEVs are sorry, the motors are best suitable candidates for EV and HEV. The very first diagram is showing this power and torque curve, ideal power and torque versus speed for EV required. And on the second slide on the right is second figure on the right shows that this engine torque and power curves. Here you can say the torque curve is dropping and power curve is rising. And the third one is motor characteristics, and fourth one is modulated characteristics. Here what I want to convey is, for a vehicle these are the ideal torque speed characteristics required. But here you can see the motor torque speed characteristics. Motor torque speed characteristics are ideally suitable for these torque and power characteristics of the vehicle. But you see the engine characteristics are not directly correlating with this ideal requirement. Then how do you connect the engine, and from the engine how do you are getting the your ideal required power and torque? Here you can see these engine characteristics are modulated with the help of the gearbox. Here in the vehicle you must have seen in your car also different gears, first gear, second gear, third gear, and fourth gear. Basically with the help of these gears what you are doing, you are modulating the engine characteristics, okay, so that that characteristics are ideally similar to this required for the vehicle. But this is not required in case of the motor, because motor characteristics are ideally suitable for the vehicle power plant characteristics. So what I want to convey is that this electric motor is the best candidate for the vehicle torque and power requirement. Okay, that's why the energy improvements or this efficiency improvement concepts are coming. And if gearbox are most of time not required, but if sometimes people are using gearbox also, because in case of the motor also, if the vehicle torque requirement is very high, then the motors availability torque from the motor may not be sufficient in that case. So in EV and HEVs also sometimes the people has to go for gearbox single stage or two stage reduction in the gear using the gear. Then these are the different HEV configurations. The first one is series. From the elements of these, from these elements you can make out. See, you can see here engine, generator, battery, motor, and transmission. All they look like in series. That's why this is the configuration of hybrid. Sorry, series. The second one is the parallel one, wherein you can see this is the motor and engine. They are coming in the looking like in a parallel fashion, and finally that is driving a transmission. Third concept is also possible, that is called as a series parallel hybrid vehicle, but this is very complex thing to do, and people should avoid this series parallel concept. Most of the times people are opting for this first one or second. Mostly parallel hybrid is best thing to do. Here in VRD we have attempted for this development of this parallel hybrid vehicle. I would like to explain that case study, but I will not explain much regarding this now due to time issues. This is a parallel architecture. This is the two transmission design, and this is the present status. I will come to case study. I will just briefly cover these important EV and HEV technologies. The three very important elements are control, then motor generator and power electronic aspects, and energy storage, in the sense batteries basically. The control is again, it will play a very important role, energy management and drivability control. Okay, then how to control the engine and motor power smoothly. That is also a very important aspect. How to control this regenerative braking and mechanical braking in this EV and HEV. Then embedded control things to control overall vehicle. Then second key technology is this motor generator and power electronics. Nowadays, these very high performance permanent magnet motors or permanent magnet synchronous motor generators are available in the market. Basically, why the people are going for this is in the vehicle, most of the times weight and space constants are coming out. And if you want to have very fit in, uh, the high powered machines, okay, in the less envelope, then that time these permanent magnet motors and generators are coming into picture due to very high flux density, use of very high flux density and lightweight machines available in the market. Induction motors and generators are used, but nowadays most of the people are switching over to these permanent magnet motors, BLDC and PMSM motors, due to weight and size issues. Then this is related to regenerative braking, but the point which I want to convey here is that whatever energy is lost in braking, no, that can be recovered using EV and HEVs. That is completely possible over here using the controls. This is where I am showing different motor candidates available for this EV and HEV, like DC motor. You can go for DC motor, induction motor, permanent magnet motor, and switch reluctance motor. These two last two candidates, that permanent magnet motor and switch reluctant motors, are best candidates. But cost wise and ruggedness wise, induction motor is also suited because due to maintenance issues. But wherever envelope permits, induction motor can be used. But wherever envelope and weight issues are there in these permanent magnet motors are best preferred. This is third technology related to batteries basically. Here you can see the specific power and specific energy. Now specific energy in the sense specific energy in the sense that energy device will last for longer times, that is watt hours per kg. Specific power in the sense you will have the burst of powers. Okay, you can draw in very high currents but for short duration. And in energy you can draw a constant current but will for a longer duration. So here what I want to convey the message that here you can see the device ultra capacitor, which can give you very burst current but very for short duration in terms of milliseconds. And you can see here for long term, if you want for energy device we having high specific energy, then fuel cells are coming into picture. Then gasoline and this IC engine based devices, there is no match for it. But as far as these EV and HEVs are considered, one has to go for nowadays these batteries. You can say in the batteries again there are different types: lithium-ion batteries, lead acid batteries, then nickel cadmium batteries, nickel metal hydride batteries. But again, one has to find the best standard suited for this EV. Whatever comparative study which we have done at our end in VRD and DRDO, lithium-ion batteries nowadays are best candidate suitable. And nowadays in the market there are a lot of manufacturers available who are manufacturing the batteries. Okay, lithium batteries also. So, and time is not too far that these lead acid batteries will be completely replaced by these lithium ion batteries, because day by day as the time is progressing, this cost of these lithium ion battery cells are decreasing. We have attempted to develop this ultra capacitor at CMERI with the help of CMERI Durgapur, okay, for defense application, one for unmanned ground vehicle. That's what I want to highlight over here. And we have developed few lithium-ion battery packs also at VRD for unmanned ground vehicle application and for HEV application also. Here again, these different energy densities of different batteries I'm showing, but that topic I have explained. This again comparison of these different battery packs like lead acid, nickel cadmium, nickel metal hydride, and last one is lithium ion. You can see there is a cycle life of lithium batteries and energy density. Energy density of this lithium battery is highest in the sense its weight is very less as compared to other batteries. For example, if lead acid battery weighs 100 kg for same age capacity, lithium ion will only weigh up to 25 kg or maybe less than that. This is again exhaustive comparison of different battery characteristics like efficiency, low temperature operation, charge retention, power density, energy density. Okay, for different chemistries like lithium ion, nickel cadmium, nickel ion, nickel metal hydride, silver zinc, and nickel hydrogen batteries. These are the characteristics of different systems. But now I think I will not explain this. What I want to convey the message here is you'll have to operate the system at their optimum operating region, all the systems. Then and there we can extract the best out of your EV or HEV. This is the military interest, basically why the military is also nowadays in our user army, Navy and Air Force. They are also nowadays they have started for looking for these EVs and HEVs. Okay, the reason is this is the largest item on their budget also, and it helps them in logistical issues, in some tactical issues like silent mobility and silent watch. And capability wise, these vehicles are better. They have the better range and they can export the power to other vehicles also. And mobility wise, one have improved fuel economy, then improved control, good acceleration, and in system integration also you have flexibility in placing the components, because in EV and HEV you will a lot of components like gearbox and all these mechanical linkages will be reduced, so you will have the space, and you can have some value added features and reduce signatures like thermal and acoustic signatures will be reduced in EV and HEV. So these are the different vehicles, electric vehicles available with US Army like M113, LAV, M915, HMTT, and this AHED. These are the different vehicles which overall US Army is using. And now I'm coming to this VRD case study. We have converted Swaraj Mazda bus, complete bus, on a hybrid vehicle concept. Okay, that project was 1998 only. We did the extensive trials of these vehicles. Okay, all project our goals were achieved, but complete bus was converted. That was a series hybrid concept over here. The second project which we did on must have heard again Tata S vehicle. This Tata S vehicle we have completely converted into a parallel hybrid vehicle. This vehicle is running nowadays and we are collecting the data. Basically, this vehicle has 5 different modes like engine only mode for highways, then electric only mode for city and silent operation, hybrid mode for gradient climbing and high power zone, then engine oblique charging mode, charging the batteries during cruising the vehicle, And regenerative braking mode is also there, like for charging the batteries during downhill and braking of the vehicle. And here in parallel hybrid vehicle design objective, where we wanted to have a parallel hybrid to recover the energy region in regenerative braking to maintain the battery state of charge. Then in this parallel hybrid concept, this is the actual transmission line. You can see drive line basically. These are the wheels. These wheels are driven with the mechanical transmission. Okay. After that, mechanical coupling is there, battery charger, motor, and this is finally a mechanical coupling. Here you can see the engine and motor. They are directly coupled to this mechanical coupling. The two shafts at different speeds are connected to a transmission. Okay, and here the type of vehicle is a parallel hybrid. Total modes are 4. IC engine, same engine was written, and here the maximum power from the engine is 11.3 kilowatt. This 8 kilowatt 3-phase induction motor we used, and lead acid traction batteries imported from the US. That Trojan make we have used in this vehicle. This is the motor basically. Motor with this motor we have achieved the speeds up to 57 kilometer per hour, and this is the motor drive, and these are the batteries 215Ah 72 volt battery bank we used in this. And here you can see the torque speed characteristics and the motor integrated on the vehicle. The motor specs are also specified here. 8 kilowatt 3-phase induction motor we used. And this is the motor.
Lange sir, can you make it faster?
Yeah. This is how we calculated the motor power rating for this vehicle. And now this vehicle we are developing unmanned ground vehicle. We are developing with CSIR, CMAR. Dr. Ray is only this principal investigator for this. I will not speak much on this. I think now I will conclude. Actually, we did, at our lab, we are planning to convert our VAP, wheeled armor personal carrier, that is 8x8 vehicle, into this, full electric vehicle. For that, we did all homework, and that final proposal is in the final stages. That one of the vehicle you must have heard regarding it through the internet. But now we are converting that now into EV. What I want to conclude is, this development regarding these electric vehicles, hybrid vehicles, or fuel cell based vehicles is progressing very rapidly in the country and all over the world. Okay. Now the fuel economy of hybrids basically depends on their driving cycles. Okay, they can significantly contribute in reducing the emissions. Okay, and the three key technologies are there, like control, then motor and its drive, battery, or you can say the energy storage. Okay, and the people nowadays should strive for clean and efficient vehicles nowadays, and we in defense also we are trying for the same. Well, thanks a lot for patient listening. If you have any questions, please ask.
Thank you, Lange sir. We will just take up questions. Just we have 2 more presentations left from CSL side. So there is a session for panel discussion. Just be with us at that session within 10 minutes, 20 minutes time. We will listening in that panel discussion. So, sir, thank you very much once again because robots and electric vehicles, they have intersecting zone of interest. So obviously your presentation is helpful to us. So whatever questions, if anyone having any question, we will discuss in the panel discussion. So thank you very much. I will now welcome Dr. Ravindra Singh Beast from CBRI for a presentation. on the works being carried out under his guidance. Dr. Beast, please.
इसमें एक ही बंदा जनून लग रहा है मुझे, ट्राइडेंट।
ट्राइडेंट से ही लेना है सर, वही सप्लायर है ओनली।
Sir, please mute yourself.
My presentation is visible, sir?
Yes, it is visible. Please carry on.
Respected team nodal coordinators and distinguished panelists, audience, very good morning to all of you. So today I'm presenting the work which we have carried out related to robotics for inspection and cleaning of civil infrastructures. So we have in the recent past, we have worked on two major activities. One is the robotic inspection for ferrous structure, and second activity related to the robotic development of glass facade cleaning robot. And if we look at the different infrastructures and also some of the latest review article, they are also suggesting the infrastructure, above ground infrastructure are very unsafe, hazardous and very time consuming for human operators. And because they require routine and periodic maintenance, cleaning, surveillance, and like other applications, and painting and some other like structural health monitoring is also one of the important aspects. So typically, if you look at some of them are ferrous, some other are non-ferrous. So, and we require robot which can crawl in these varieties of wall materials. So some of the important challenges are the mobility of the robot. So how the robot will have mobility on these structures when the robot will crawl. So mobility in the sense we require locomotion. Another is very important aspect is adhesion. Adhesion by which the robot can stick on those different wall materials. So we have done a lot of investigations. In terms of locomotion, as all of us know, wheel, track, legged, all of us know, they can be similar to ground mobile robots in case of wall climbing robot. And initially we have focused on the bio-inspired and electro-adhesive mechanism. Bio-inspired, it's a kind of gecko. I use the millions of here, and it's a kind of van der Waals force and net force, at least the gecko weight can sustain. But still it is under research phase, and we found some analytical model also get low force. From implementation point of view, it was very difficult. Then we switched to electro-adhesive. Electro-adhesive is another very important mechanism which can be used for a variety of wall materials. And we have done analytical, experimental and simulation, but still we found it produces only 15 Newton, in the range of 15 to 20 Newton. So from implementation point of view, because in field we require robot which can carry payload around 5 to at least 10 or 15 or 20 kg payload. So payload is a very important aspect in the wall climbing. So we require adhesion mechanism with high adhesion force. So we separately worked on the magnetic adhesion, the mechanism which we developed. It produces very high force, adhesion force. It is around 250 Newton. It can produce. So we can develop robot with high payload carrying capacity. So after extensive wheel optimization, design optimization, and then another that important aspect is non-ferrous. Non-ferrous, we focus on that suction. Again, in suction, there are many ways to develop the adhesion force. And we worked on the two concepts, active vacuum and passive vacuum. And active vacuum requires some external means like vacuum generator and pump. And however, in the passive vacuum is more efficient. Without, it's just a mechanical press, it can produce vacuum. So some of the detail can be seen from all the published papers. Now coming to the activity one, which is related to the robot for ferrous structures, we have developed this autonomous robot, and these are the technical features. It's very compact in design, everything on board and wirelessly we can control. and it has very good payload capacity. We measured static in a static way, but however in dynamic it can have up to 10 kg payload carrying capacity. And we have deployed in the field. Here we can see some of the field trials. One, we used a Wi-Fi camera by which we can get the videos in our ground station and also the images. And for example, in civil structures, there are damages like corrosion and some failures in the bolts and other joint failure. Another very important aspect we have developed, like we use a MEMS wireless accelerometer. Instead of in structural health monitoring, instead of using multiple sensors, we can have two sensors, one sensor with the robot, another sensor with the reference sensor, and by which we can reduce huge instrumentation cost, and this process can be very efficient. Both the theoretical and experimental study we have done, one is using multiple sensors, another robot with sensor, so that we have tested. Now this same magnetic crawler we have updated. What happened that many truss structures and civil structures, the ferrous structure are complex in nature. Sometimes robot has to move from vertical to ceiling, ceiling to, the transitions are required, wall to wall transition, and also obstacles will be there. So for that purpose, we developed a new concept which can use coupled wheel and arm locomotion. For that, initially we have worked on the extensive design and then mathematical model. From the mathematical model, we have selected suitable actuators. Then trajectory tracking is also very important aspect. And some of the detailed our analysis, experimental validation of the concept can be seen from the Robotica journal paper. And we have also filed the patent, this technology. And apart from laboratory, extensive work at laboratory, we have also tried at field level. Further, it requires, because these are prototypes, we require proper that products as in the form, and we can join hands with the industry and other our sister laboratory for the implementation point of view. Now, next activity, as I said, the glass facade cleaning is one of the major issue. Generally the people, they hang, the operators, they hang, then clean, and sometimes it is very unsafe. We require this robotic system which can crawl, but the challenges are when we use conventional, sometimes they are unsafe. So we require some autonomous robot which can clean. We developed mechanisms. Again, we work extensively on mechanisms. Here we can see there's some animation. It shows the multi-section curve, and the challenges are the actuation and deactuation of the vacuum. One way we can have the activation and deactivation of vacuum using solenoid valve, but again it increases the weight of the robot, and at the same time it increases the power consumption. Then we thought of some mechanical that check valve. Mechanically, when we press the piston, it can have on and off vacuum operation, and also the residual vacuum can be released. And there is one guide ray here. We can see it has a cam profile, so that the suction cup which are on the surface, they will have vacuum, rest other will have no vacuum. Apart from those timing belt, at the center there are we also use the round deep groove suction cup. They have dual purpose. One is the safety of the device, and second is for the steering, sharp steering of the robot. We have also measured the vacuum fluctuation. In many literatures, I'm saying some other literatures are also reporting this similar kind of investigation, but in our system that vacuum fluctuation is very low compared to other system. Then some gaining confidence from the laboratory level, we also try to clean solar panel, and apart from the solar panel, we require path planning. Path planning is very important. Cleaning a facade, for example, I'll take 2.5 meter into 2.5 meter glass facade. That the field, we went to the field, and different path planning, horizontal line sweep, vertical line sweep, and which path is most energy efficient. That is very important. And also the sharp steering, so that the full coverage while cleaning, the coverage efficiency is also another important aspect. So that we have done from simulation, from mathematical modeling, and but there are some observation like in tracking there are errors. We found some errors because robot is moving against gravity. There will be a sliding. That sliding we have to compensate either feedback control and either using the heading control that we have worked, and further those trajectory can be improved. Some of the results can be seen from our published paper. And if I summarize both the activities, the activity one, robot for the Ferris structure, it uses the combination of wheel and arm. Suppose the plane, it will work according to the surface condition. For example, plane surface, it will use the wheel locomotion, and suppose it has to avoid obstacles and moving from one wall to another wall, and complexities are there. Suppose, for example, corrugated environment, there it will use the coupled wheel and arm locomotion. It's a bio-inspired compact design, and we have tested autonomously. And right now the TRL level we are expecting 4 to 5. And similarly, the other activities, that glass cleaning, we have to further it requires a rooftop assisted system, because it can autonomously clean a particular facade. But in multi-story, there will be multiple facade. For positioning from one facade to another facade, it requires a rooftop assisted system. We have to implement, and also we are focusing on totally passive vacuum, so that the power, it will be more energy efficient in compared to other available. Our future direction, as I said, above ground structures like robotics, automated entity inspection. We also focusing. Some of the entity inspection requires precise contact, which is not possible by means of drones and other, like subsurface defect, measurement of subsurface defect also required. But this kind of robotic system, and also I'm not saying drone wall climbing drone can also be very useful, so that we can also think in the future. Apart from inspection, surveillance, cleaning, painting, and repair application in unreachable location can be very useful for the robotics. And not only above ground structure, there are underground also, like sewerage system. Sewerage system, we did a joint project with Durgapur where we worked on the mechanized aspect. But now robotics can be very useful, where because in many pipe size, in fact 80% worldwide, those sewerage system are classified as no man entry because their diameter range is less, 50 mm to about 300 mm. So which is possibly very difficult for the human operators to go inside, and so this thing. So this thing can be taken care. I'm thankful to for giving me opportunity to team nodal coordinators and my all team members, and also those who are directly and indirectly involved in this project. I'm thankful. Thank you.
Thank you, Dr. Beast.
Yes.
Hello.
Yes, sir.
Yeah, thank you, Dr. Beast, for your nice presentation, and it's a very nice to see numbers of mobile robots being developed for your this at least vertical wall cleaning and inspection. It's a challenging task. So thank you very much for the presentation. Now, on behalf of CMERI, I will just present a few work carried out at CMERI under this civil infrastructure inspection and manufacturing. So probably my slides are visible. Is it okay? Hello?
Not yet, sir.
Not yet, not yet. Is it blank slide? First slide is blank?
No, 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 no. Just 1 minute. Screen. Entire screen. Allow. Is it visible?
No, it's showing Dr. Ray is starting to share content.
Okay. Let's watch.
The speed be probably.
Swedish. Okay, just the time is very short. Let's discuss the things. Basically, we are in CMERI. We are working in two different domains. One is that is the surface type of robots, and another is underwater robots. So under this inspection, there are a number of different infrastructures we have already inspected, and we have a number of issues in the future to solve. First one, that we have a teleoperated mobile robot for mine tunnel inspection. Basically, that is a project funded by Coal India, where it is very much necessary to find the subsidence or inclination and other issues of a particular mine tunnel. So a teleoperated mobile robot, and with which has a you can say the range of around 50-meter teleoperation capability was there. So that robot was carrying one laser sensor on top of it, and it was moving inside a mine tunnel. And each and every tunnel, if you go on collecting the data for a particular interval, say every week, say at the beginning of every week, so you will have a particular profile of a tunnel. And if you compare that profile on of the tunnel over time, obviously if there is any deviation of the width or height, which may lead to your collapse of roof or collapse of wall, that can be warned. So this is one of the domain, means where this mine tunnel was mapped and inspected. So that has been trial at one of our nearby ECL colliery. Next one is that CMERI has developed two different mobile robotic system. One for boiler header, as Dr. Mondol from NTPC Netra already shown you. I am not going into the detail of the thing. So one is this remote visual inspection of boiler header, number one. Number two is that this CW sump and pump CW sump and pump inspection robot, which are very useful. One for boiler header, as you know, it's a very constant space, and it is very difficult to inspect without any human intervention. So those two robots have been developed in collaboration with NTPC, and had been trialed multiple times in different NTPC plants, and still they are working. So thereafter, another important domain where CMERI likes to work, or already have stepped for a little bit work, one that is robotic bathymetry survey, because the navigable channels of coastal water or other inland waterways, often there is sediment, there is gathering of silt and sediments, and as a result, there is an issue with depth. So there is a problem for movement of ships and vessels. And for this, nowadays, manual bathymetry are carried out. CMRI has developed a automated surface craft, which has been tested in a local water body to find out the bathymetry data of that particular water body. And a similar concept or similar this technology can be being scaled up for doing bathymetric survey for a river and other bodies in the future. Next one is that, as already you have seen, numbers of inspection, aerial inspections by drones are going on. CMARI is also not lagging behind. CMARI has developed or integrated one such drone and deployed it in nearby thermal power station of DVC. And there are all the things, means power station overall survey, then inspection of the ducts and rusted structures, as well as inspection of the chimney has been carried out by a hexcopter UAV. And as per the need from different agencies or organizations, we are also working in this direction to provide solution. Besides that, as I told you, surface robots are also there. There has been developed a pipeline inspection robotic system to find out the gas content of any pipe. Though a such robotic system has been designed, developed, and tested, so it's now waiting for real time collaboration with other industries, where this type of pipeline gas, at least gas or low gas pipeline inspection is required. So that work is also going on. And another important thing, as Dr. Beast told, that storage inspection. CMRI has worked in this field also. Apart from mechanized cleaning, CMRI has developed two different robotic prototype. One around having a diameter, means having the operation capability in pipes or storage lines with diameter 500 mm, and another is above 150 mm. Means there are two different robotic system. One can operate in the range of 500 to 600 mm, and another is above 150 mm. And there, this small one, this robot can move in the sewage water and capture the online video, as well as image processing has been employed, so that you can see the original image, as well as some image processing techniques has been used to identify any cracks or other obviously surface cracks or other irregularities is there on the surface of the Suarez line. So these two works have been also carried out and tested in the CMRI colony. Apart from that, as you know, this domain of robotics is continuously upgrading. So we are also doing work in hand with various other ministries, defense and other coal ministry, where we are developing different mobile robots, autonomous mobile robots, and with the various types of mechanisms they being developed for the cater the need of industries and other organizations, etc. Also, we are in some of the cases we may need to develop the components. We have to do a substantial research. So CMRI also is in that business, and CMRI is also using this robotics for manufacturing. We have a different type of wire arc additive manufacturing robot and welding platform, where we have developed a clutch plate, sort of valve body, etc. Because there is a advantages from your manual welding and manufacturing in terms of directional solidification, large volume deposition, etc. So in that way, manufacturing means robotic manufacturing is being used also. But you know, there are lots of problems to be solved in the future. So we have also identified some few such problems, such as robotic system for inspection of bridge pier. You know, some of the bridges are submerged in water, and they need to be monitored regularly for corrosion and other type of failures which may happen to this type of structures. So there is a opportunity already. Some work in the international level is going on, but in India, this type of work is very much needed, and CMAR is looking forward for such robot-assisted inspection for the bridge fires. Then, as I told you, CMARI has a multiple robotic system for remote inspection, monitoring, etc. So, just a few weeks back, we are collaborating on one of the Indian industry carrying carrying and supplying gases from one location to another. Cross country pipelines are there, which need to be surveyed from the surface. That is a very big challenge, because now they are doing manual survey with some handheld instruments, but they cannot approach very dense forest or marshy lands where there is a chance of human life risk. So there we are trying to implement robotic system for inspection, survey and inspection, as well as the pipelines. Though there are number of technologies that available commercially, basically we all know peak, that is portable inspection gauge for various type of pipelines, but some pipelines are there where these are not useful, because when there is a change in diameter or the diameters are very less, then these peaks, commercially available peak, are not useful. So CMERI is handshaking with these industries to provide solution in this domain, remote survey and inspection of buried pipelines. And apart from these, as you seen that we are working with Coal India also. There is a need, about mine fire in the Jhoria area, where it is very difficult to continue the mining operation. Even on the surface, fires are there. So robotics can be used to save those mine galleries. And the coal, huge amount of coal can be saved. So in that direction, CMARI is also has joined with Coal India and this Eastern Coalfield Limited to provide a solution, and that collaboration work is going on, just in the initial stage is there. Apart from that, there is another two important thing is that, as often these pipeline inspections are possible, but in situ repair is another important issue to be taken care of in the future. So with the help of CBRI Roorkee, CMERI look forward for robotic repair of sewage pipeline, because their CBRI owns some special technique to localized repair of these sewage pipelines, old pipelines, so where this type of robots can be employed, and this repair can be done. So similar type of activities also can be supported to the industries. And finally, I am also to inform that these are some of the robotic inspection we are using. There is sensor data fusions are there, communications are there. Still, as you know, as the reality demands, there is implementation of AI engines for inspection. Currently, we are in the proposing or proposal stage of one of the work where we are using ground penetrating radar data from ground penetrating radar. It is just a two-dimensional image. It's just a giving you some convolutional shape image of a buried object inside the underground soil or any other structure, and those images for known objects can be gathered, and a classifier can be made, AI based classifier, and same that classifier model classifier can be used in real-time prediction of the faults or defects that is available under the ground surface or in the structures there in internal structures. So we are also working or implementing AI or using AI in this type of inspection and monitoring. So these are the wide domain of working of CMARI, and any collaboration in this or this exact domain may not be possible. Other areas is welcome, because CSR itself is providing solution to the industry. With this, I end up my presentation. Now this session is open for panel discussion. Though I understand that the time is already we are very late. Still, let us allow 5 to 10 minutes for the panel discussion. So whoever have any question can ask one by one.
Hello, I am Shrigod here.
Yes, sir.
I have a question for Mr. Datta, Supriyo Datta. He explained the rebar cage production using robot. So what is your experience in repeatability of the end product?
Okay.
Okay, please continue.
Yeah, sir. Please, you complete the question. Sorry.
No, that was the question only. Repeatability.
See, it's a very good question. Primarily all the rebar elements are now currently being done by CNC bending machines. The challenge is when the operator unloads the material, the reference of is lost. So basically, if you had seen in my presentation, we are talking of a specialized trolley. So the bar is located in the trolley with a reference, and when the trolley is presented to the robot station, so if you look at the fixture, it takes the X and Y dimensions, takes care of it. Now the only challenge is the height. So when we are taking it, we are taking the component by a self-centering gripper, and when we are dropping it, we are sensing with the ultrasonic height sensor, and we are dropping the part in that exact groove. So in terms of repeatability, we are able to operate with the industry repeatability tolerances. It is working fine. If you have a CNC bar bending machines in the back end.
Right. Okay. And one more question. With this project may need a lot of standardization.
Yes.
Input stage to the layout area and hardware, etc.
Correct.
So from capital cost point of view, is it okay, or the payback? In fact, what is the payback for this complete setup?
In terms of yes, it's a very good question again. See, in India, there are two ways you look at it. In terms of payback, yes, it was not justifiable, but now if you have a project and you have a tunnel section to be made, and you have to be made in two years, and the sections are long and your designs are changing. So even if you put manpower and you are trying to execute this project, it becomes very difficult to manufacture it manually. So when you are looking at in terms of cost of operational cost in terms of your project timelines, this payback is working. It is working for the current situation.
Okay. Thank you.
The only challenge what you had pointed out is repeatability. Is you need a lot of fixturing. Trolleys. You need to standardize on them, and you also need to sense them, and you need to also one aspect which is missing out in the whole aspect is you need to train your manpower. So we are that's another challenge with moving from a manual system at one jump going to a robotic system.
Correct. Yeah. Thank you, Mr. Datta.
Thank you, sir. Thank you.
Anyone else?
Dr. Ray, may I suggest something in this rebar connection?
Yes, sir. Yes, sir.
Yes,
Why not? Please.
actually, precast construction. Say there are thousands of piles are to be made, say for large bridges. This type of technology is very useful, and some Koreans and others are making in fact as a precast construction within our campus in the factory we can make such system, and that is very useful. To replace at the site, it may be not be cost effective. Thank you.
Uh, anyone else? So there is a means need. There is a multiple challenges in the industries which can be solved by robotics itself. So nowadays, numbers of solution have been provided by CSIR and other organizations to industry. Still, there are numbers of problems need to be solved. Means that is the main objective of such type of interactions, where the capabilities and strength of different CSIR labs and other industries can be shown and can be mutually think. If there is no question or
Can I ask one question?
yeah, you introduce yourself first.
Yeah, I am S.S. Garwar, Senior Principal Scientist, ESIR CRI, New Delhi.
Okay, sir. Please.
My question is to the gentleman representing NTPC.
Yes, sir. Tell me, what is your question? Yep.
Just I wanted by introduction of these latest gadgets. What is the change in the you can say O&M cost on different you can say applications infrastructure where you have deployed this?
No, actually the situation is as I was telling, no, because of the dominance of the renewables in the grid, no. So most of your power plant, especially thermal power plant, you are partial load during day and full load in the night. So your components is exposed to fatigue damage. Okay. So as you know, because most of the power plant design was for base load, now you are running it in partial load. So this accumulated fatigue damage is consuming its life. So if you are not putting or increasing cost, so catastrophe will happen. So that was the premise. Most of the area where we were earlier, inspection was not required. But now if you're not putting enough effort, you will miss this thing and catastrophe will happen. So that's how overall O&M budget has increased, and majority of the budget is taking foreign vendors because of the readily available and rugged device supplied by them. So we can indigenize these things because most of the vendors, they are giving you the general purpose robots or drones, but there is customized robots for special areas of application. So do you getting my point, sir? I mean, what? Yeah. So those are the area. If you can take those problems and try to solve it, most of the time you can solve it. We did it with CMS, Singapore, two problems, and another two problems with Madras, and other two in NML. But the problem is, until or unless you are sticking it to it till it became a commercial product, so you are losing your time and energy. Because like that magnetic crawler, we started in 2010, but by that time prototype happened, started giving the services at different point. But then some Canadian, they came and readily giving you the product. And your product will not become a successfully commercial product. But last two products, especially one is for header inspections. We are sticking it with Dr. Ray's group, and we are putting since 2019 we are on this thing, and already two we have worked and deployed it. And as I was telling, almost 70 units we have inspected, and more than 100 number of headers. The prototype device has sustained. So it speaks a lot. Now that if you can do little bit of further modify, I am sure that will become a, and I mean like commercial product.
My query exactly how you go for the commercial bidding, because I believe that for your real life problems you are seeking the commercial bid. How you are going for preparation of those bid conditions, how you are interpreting this CSIR labs.
Oh, sir, the question is not clear. I mean, can you rephrase it, sir?
Actually, Dr. Mondal, just the question is that means how you go for bidding, means before awarding the project to a CSIR lab, means how you carry out the process. Just in our case, procurement, L1 case is there, we put tender and the things. So he wants to know the actual procedure.
See, for government or lab like CSIR, we have a flexibility. If we are really confident and you know somebody who is initiating the project, he is confident enough and he can convince his management. In this case, our NTPC people, if we can give them the confidence, it can be solved by this group or by this lab, and because they have that credentials credibility. With CSIR lab, it will become easy, but for private players, it is an open tender that you know lowest bid players will come, and that is actually backfiring, because once you are going for open tender and least bid, no, people during the tendering process they are agreeing everything, but later on, you know, during deliverables, so they are missing most of the points.
Okay, thank you.
Okay, thank you, sir. Thank you.
Any further question?
I'm Shrigod again, Ramesh Shrigod again. I have just
Yes.
one comment, no question, but just one comment. We are talking of a lot of technologies in robotics, vision system, then digital twin and etc. in civil and industrial part also. But same time, my experience is we are facing a problem of getting trained manpower in these areas. Technologies are changing very fast, but I think our college syllabus, at least for ITI holders or diploma holders or engineers, those should take care of basic technology part. Specialized training and those things industry can give, but I think this changing conditions should get reflected in the college syllabus also. That's what I think.
Namaskar. This is a very nice suggestion, observation. I will put it in the minutes itself. Yes, it is very true. Just for your information, CMERIN carries out a number of such training for robotics. Okay, hands-on robot building. Though there are multiple companies in this era of lockdown and this corona, there are a number of such online based companies are there, but until and unless you know it by your hand, it is very much difficult. So
Yes.
CMERI is also working, or CSIR is also working in this direction. We are trying to impart knowledge to such college students. Basically, what we understand that yes, there is a significant gap between the industrial requirement and the academic means syllabus, which we are also facing here. So that's why we on a regular basis say whenever we have a requirement, we do training in for upgrading the knowledge of the nearby college students. Obviously, we also advertise it through Facebook and other social medias where. And here, starting as you are requiring, you require things. We are training means imparting trainings for this manufacturing, means how to write code on CNC. Then, as I told that the robotic laser welding is one part which we are doing. So we have a ABB based robot where we are also teaching the students at least what is the working and scheme of this particular operation of the robot and how the code looks, what is the structure, and by hand you do your own coding there. This is the for a manufacturing portion. Apart from this, whatever robot we are building here, we are trying to also give them this knowledge, but it may not be obviously reaching to every corner of India. So let us do our best. This is also being informed to all the participants that this type of course is being organized under this skill development program by CSIR itself, and not only CMERI but other laboratories also in robotics they are imparting training. So we are already trying our best, but that to be incorporated means this at least the advanced versions at least should be included in the syllabus. Otherwise, we are really feeling this problem, because just for your information, though we are training them in this your ARM based microcontroller and your 8051, but in BOO the syllabus still probably 8085 microprocessor is there. So it's a very tough thing. We are facing challenges. Even we are imparting training on how to make PCBs by your own hand, because being a robotics engineer, you have to have a overall knowledge of all these systems. So we are imparting training, but there is obviously a high need for the upgradation of the curriculum in respect to this current scenario, whatever going on in this robotics and AI domain. So thank you for your this good suggestion.
Thank you. Thank you. Yeah.
Any other speaker? So if no one is there already, we are delayed. So thank you very much on behalf of CMERI and CSIR to all the dignitaries. I thank our director madam, and then our Dr. Anjali Chatterjee madam, then director ACRC and CIE team director Anandavalli madam, then Ramesh sir, Rajiv sir, and Lange sir, also for your nice presentation. Then thank you very much for Dr. Datta for your this interactive session and the challenges you posed or thrown to us. We will obviously look forward to solve this problem one by one, obviously in collaboration with you. Then thank you, Dr. Mondal, for highlighting the works and the trends that is going on in terms of robotics in NTPC, where CSIR has contributed, and in the future CSIR also contribute in solving your problem. And I also thank Dr. Beast for his innovative work, so which is going on for in terms of inspection and cleaning. And apart all, thank you all the participants present there. Hope there is significant knowledge enhancement, and we have got some problems also which need to be solved by CSIR for the industries. Thank you very much. And obviously CSIR and Ministry of Science and Technology, Earth Sciences we are very grateful to them for organizing such interactive session or interactive event, without which we cannot collect such problems which where CSIR can contribute significantly. With this, I thank you all. Thank you very much. Let us see for future collaboration. Multiple problems are there, and thank you all the participants, dignitaries, and speakers for this event, and on behalf of the coordinator. Thank you very much.
Thank you, sir. Thank you.
Thank you very much, sir.
Thank you.
Thank
Thank
you
you
very
very
much,
much.
sir.
Thank you, sir. Thank you.
Thanks
Thank
to
you.
all.